We are on the section 4.2, page 23. We are going to graph linear equations. So what does linear mean? A line, right? So let's take a look at the usage of a line first. Let's go to page 22. Here says, the graph below shows how many medical assistants in thousands are expected in US the year following 1995. So if we look at the graph, a line, see what kind of meanings it has, right? Like this. So here is what? 1, 2, 1, 2, 3, 4, something, right? So here's the years after 1995. So 1 means what? 1996. 2 means what? 1997, right? So we have things like this. Then here, your reference is what? 150, 200. What does that mean? Then you look the line on the vertical line. It says what? Number of medical assistants in thousands, right? So the question is, how many medical assistants are predicted for 2004? So 2004, which number we should look at it? So you do 2004 minus 1995. We should look the reference for x. Axis should be 9, right? Then you look at the 9. Then you find out here is the point, right? Then you try to find the reference, which is what? Around there, right? This number is what? 450. So what does 450 means? It means in thousands. So that would be so many medical assistants according to this prediction chart, right? Good. And for next one, on your page 22, next one, just skip it, okay? Let's get back to your page 23. Let's see how we are actually going to graph a line. Okay, first we figure out if there is a line, what does that mean, and how we actually use it. So here says, what is a linear equation? We are going to graph lines. So first we define what is a linear equation. On your page 23, it says a linear equation, first degree in two variables has the highest power on the variable is what? Right? So if it is a linear equation, we are talking about what? In two variables. We are using two variables now, right? Then has the highest power on the variables is what? Has to be equals to 1. We have two variables, right? So we have x and y. So for each of them, the highest power has to be 1. That means if x means power is what? 1, and y power is 1. If it's 2, power 2, then we will not call it linear equation. right? So when we graph a linear equation, it must be a what? Has to be a line. So that's why we call it what? Linear equations. Okay? Then let's see how it actually works out. Okay? First, we identify the format and the symbols we use according to the name given. We call them what? Linear equations. Okay, so first we identify them. If we write y equals 3x plus 7, is this a linear equations? We have two variables, right? In two variables world. So yes, because both powers are what? 1. If we write y equals 3x squared plus 7, is this a linear equation? No, because power is 2. So we will not call it a linear equation. If x is 6, is this a linear equation? We are in the two variables world, and y is missing, right? But x power is what? Still 1, invisible 1. It is still a linear equation. Just 1 is missing while working in what? Two variables world, right? If y equals 3 to the x power, what do you think? It's very different, okay? This one is not. Why? Because we said two variables and x and y's. Those x and y's has to be what? Have to be bases. Okay? They are not in the power positions, not the powers, not in the denominator. Okay? It has to be, both have to be what? As bases. Okay? So those are the things we call them what? Linear equations. Otherwise, we wouldn't call them linear equations. And we also going to write those linear equations in standard forms. Okay, so we need to identify them. What kind of things we call them? Standard form. It's important. Okay, so if we write them in standard forms, it means this way. We have what? X and Y's, right? For the linear equations, so x and y have to be power of 1, okay? But you might have 3x, you might have 4x, or 7y, right? So we do this way. We put something in front of it, we call it coefficient. For x and for y, we use b. We add them together, can be positive, can be negative, and equals some kind of number. It means what? When we write an equation, and when we put x and y on the left-hand side of the equation, and put only number on the right-hand side of the equation, then we call them what? A standard form of the linear equation. Then your A, B, C are real numbers, can be, half can be -7, can be positive, it can be negative, okay? Can be some other kind of numbers. You will learn later as well, okay? And one restriction will be what? A, B are not both 0. Okay, so what does this one mean? If A, B both 0, 0 are 0 is a real number, right? If both are zeros, so do you have anything? You don't have anything x, y anymore. You will not form a linear equation, right? You have to have x or y. But if you have x is 0, I mean A is 0, if A is 0, what do we have? This 0 times x is 0, you have by equals c, right? Just like, okay, y example, so y is, say, 7. It is still a linear equation. If your b is 0, not both zeros, right? So you will have this one gone, so you have ax equals c. That means, you know, example, x equals 5. Things like this. 1 is missing, but you will still be called what? Standard form. Still a linear equation in the standard form. Okay? So first, we identify what kind of things we call a linear equation. An equation with what? X and Y's. But one of them may be missing. Okay? But only power of what? 1. Okay? Then we identify then what kind of things we call standard form. So let's identify them. If we write 3x minus 6y equals 9. So do we have an equation? Yes. Do we have a linear equation? Yes. Is it in a standard form? Yes, because x and y and are on the same side of the equation. If we write -3/5 x plus 4y equals 0, is this a linear equation? Yes, x and y equals, then numbers, coefficients can be what? Fractions. So is this a standard form of a linear equation? Right? If we write it this way, is this a standard form? No, why not? Because x, y are not on the same side of the equation. If I write 5y equals 6, is this a linear equation? Yes, except what? X is missing. If x is missing, it's that same thing as 0x, right? 0 times x is 0, plus 5y is 6. Are they the same? Yes, right? As long as x and y's are on the same side. Okay? Let's look next one. If we write x is 1, is this a standard form? Yes. You can write what? X plus what? 0y. Right? So this is 1x, invisible 1, and 0y equals 1. That's what it means. So it is a standard form. Now we are going to graph some lines. Okay, so let's see how we actually do it. So we were identifying what kind of things we call them linear equations. What kind of things we call them standard forms, right? Only one x to the 1 power, y to the 1 power. One of them may be missing. And if both x and y are on the same side of the equation, we call them what? Standard forms. So let's graph some of them. Okay, so finally we do this way. We say if x plus 3y is 6. So do I have a linear equation? It happens. Do I have a standard form? Yes. Okay, so let's graph it. We use t-table with 3 points. So we have x and y. Then we can use what? 0, 1, 2, a few points, right? Then we will identify them in what? On the rectangular coordinate system, x and y's. So that's your x-axis, y-axis. So when x is 0, what's your y? So you plug in. So x is 0, right? So 0 plus 3y equals 6. And what do we have? So 0 plus 3y equals 6. And y will be what? 2. Where is your 0, 2? 0, you don't go left and right. Then 2, you go what? Up to 2. So that's your 0, 2. We find a 1 point. Okay, we try 3 points. And if x is 1, what's your y? So when I have x is 1, I plug in 1 plus 3y equals 6, right? Then 3y equals 5. Then y is what? 5/3. Yeah, it's not a good number. You can graph it. On your graph, it will be 1 and 2/3. You can do that, but not a good number on the computer for you to graph. So we don't like that. Let's just skip for the fraction, okay? How about 2? So if I have 2, that will be 2 plus 3y equals 6 minus 2 on each side. 3y equals 4. Turned out is what? Y is what? 4/3. Still not a good number, so we don't use it. Okay? So what do? We find the next number, 3. When you plug in 3, then 3 minus 3 each side, y is what? 1. Oh, that's a good number. So we do what? 3, 1. 3, 1. Okay? And if it's a 4, you plug in, you will find out that's what? 2/3. Not so good. Okay? If you plug in 5, you find out that will be what? 1/3. Not good. Okay? So we'll do next number, 6. Then plug in x is 6. You minus 6 on each side. So 6 plus 3y equals 6. You minus 6 on each side. 3y is 0. That's 0. That's a good number. So 1, 2, 3, 4, 5, 6. 6, 0. Right? So you connect them. It will be what? A straight line. If you don't get a straight line, that means something wrong. So we are using what? 3 points to graph them with t-table. Okay? If you have 3 lines, 3 points, 2 points here, 1 point there. That means they are not aligned. You are not doing right. Okay? So you want to have at least 3 points to check, make sure you are doing okay. However, and for your homework, for the computer to graph, you only need 2 points. Okay? So on your computer homework, online homework, I think there is a icon, like they have all kind of icon, right? So you pick the icon for the line, then you pick that one, then you put 2 points in, then you should be able to graph the line. If you have problem, do your homework to graph a line, call the tutors. Okay, they should be able to show you. You go to LTCC virtual campus, then find the tutors there. And so we are graphing a line with how many points? 3 points, right? You can still use fractions. You still can do it right on the tests, but not on the computer. Okay, so usually we do what? 3 points. You use 0, 1, 2, right, to find the y, or you use 0, 2, 4 to find the y, or you use what? 0, 3, 6 to find the y's. So pick up good numbers, easier for you to find the points for the y's, right? That's how we are graphing the line. Okay, for the second problem on your page 24, so we have negative 2x plus 4y equals 8. Okay, so what do you think? We use 3 points, x and y's, so let's use 0, 2, 4. Okay, because you multiply that, then you can make a y a whole numbers. You just have to try that out, okay, to see what kind of numbers will work better for you. So when x is 0, what do you have? Plug in x is 0, so negative 2 times 0 plus 4y is 8, right? That's 0, so 4y is 8. So y is what? 2, right? So what do we have? 0, 2. 0, 2. Right? Right here. So you write the coordinate, order the numbers, order the pairs, right? Along with your point. Okay? So you know exact. So this one, x is 2. So you have negative 2 times 2 plus 4y is 8. So we have negative 4 plus 4y is 8. Right? Then you add a 4. Then 4y is 12. So what's your y divided by 4? So that's 3. So that's 2, 3. 1, 2. X is 2. Y is what? 3. So you have 2, 3 here, right? And next one, x is 4. So negative 2 times 4 plus 4y is 8, right? So we have negative 8 plus 4y is 8. Then you plus 8 on both sides. So you need to know how to solve linear equations before your exam 1. Otherwise, you are in trouble, right? You won't be able to solve it, to find the points, then to graph it. So that would be divided by 4, y is what? 4. So x is 4, y is 4. That's 4, 4. So you connect all those points, then put the 2 arrows on each side to show the line. Okay, so next one, x is to y. Okay, so what kind of points you will choose? Because y multiplied by the 2, so you better choose what? 0, 2, 4 instead of 1 and 3. Okay, so x is 0, y is what? So you have 0 equals 2y, y would be what? 0. So what do we have? We have 0, 0, right? 0, 0. Then when x is 2, 2 equals 2y, what's your y? Divided by 2, y is 1. So that would be what? 2, 1, right? Next one, when x is 4, so you have 4 equals 2y divided by 2, right? Get a y by itself, so y is 2. So what do you have? You have 4, 2. 4, 2. So you have those points, you connect them, then put the 2 arrow keys on either side. That's how you graph what? A line, right? So you put some points, 3 points for the x on your t-table. Then you find your what? Y values. Then you identify them on the graph with all of the pairs. Then connect those points. That should be your line, right? Next one. What's the difference between this equation and those? See? First two, we have what? Standard form. And this one is not. This one is not. Right? But doesn't matter you have standard forms or not, you still can just plug in your x and y's to find the ordered pairs. That's all you need, right? Even in the fraction form, same thing. Okay? So this is not a standard form. Then all you need to do is just put the points there, mainly. Right? We don't want to odd number because you have fraction for the 2. So you choose what? 0, 2, 4. Okay? So what do we have? When x is 0, what's your y? Y is negative half times 0 plus 4, right? Anything times 0 is 0 plus 4. So that would be what? 0, 4, right? So that would be right here, 0, 4. Next one, when x is 2, so you plug in y is negative half times x is 2 plus 4. Then what do we have? How do you multiply your fractions? Put 1 underneath, and so on. That would be negative 1, right? Negative 1 plus 4, that would be what? 3. So when x is 2, y is 3. So when x is 2, y is 3. So you identify them on the graph, right? That's your second point. Then let's do another one when x is 4. So you have y equals what? Negative half times 4 plus 4. That would be what? Negative 2 plus 4. That would be 2, right? So x is 4, y is what? 2. 4, 2. Then you connect them, see if it makes a line, right? So what are we doing? We are graphing a line with t-table. with how many points? 3 points, right? And it doesn't matter the equations they give to us, either a standard form or not a standard form. It doesn't matter. You can always use what? 3 points to do that. Right? Look the next one. Y equals 3x. So let's just put a point because no number in front of y, then just x. We can just put a 0, 1, 2. So when x is 0, so 3 times 0, so it's still 0. So you have what? 0, 0. Right? 0, 0. When x is 1, you plug in 1 times 3, y is 3. So it's 1, y is what? 3. 1, 3. Right? When x 2, 2 times 3 is what? 6. So when x is 2, y is 6. 2 and 6. Then you connect them with 2 arrow keys. That's how you graph. Get the idea? Right? Then let's make a conclusion. See what do they say. Okay? So what do you think? The graph of a linear equation must be a what? That's why we call it a linear equation. It must be a line, right? So all those points you choose must lie on the what? On the line, right? So every point on the line will be what? Solution for the equation. Because you plug in, it has to satisfy the equation. So all those numbers, all of the pairs you plug in must be the solution for the equation. And all those points, all of the pairs are points, right? So all those points, it means what? All those points are the solutions for the equation. Then what happened all those points not on the line? That would be what? Not a solution for the equation, because it will not satisfy the equation, right? If it satisfies the equation, it must be what? On the line, and must be what? The solution for the line, right? So that would be for our section 4.2.